Okay, and we should be live. Welcome to Advent of Code Day 25 of 25. Merry Christmas to everybody who watches this. It's been quite a ride. It's been a long day. I just spent the entire day with the family, which was nice, playing games. I just watched Home Alone with my kids for the first time, and they really enjoyed it. Put them to bed, and now it's like, okay, there's one more day of Advent of Code left. We streamed 24 days, let's do the final day, even though I'm kind of tired and we didn't even complete yesterday's one. And we have another part 2 that's not done. But I still wanted to take a look at what today's challenge is, give it a stab, and then yeah, tomorrow will be more of a family day. I don't think I will stream tomorrow, and then I will see when I can pick up, because I really want to finish all 50 stars, but just want to prepare you that it's not happening right now. And Amarte is in chat. Good evening to you too. I hope everything is well at your end. I have taken some cola instead of the normal cappuccino. It's like, let's take a refreshing drink for now. So yeah. Did you do day 25 or have you revisited day 24? Because we talked about day 24 for a little bit, and we noticed that there was a small, like a discrepancy or a few false positives because of the large range of numbers. So I was curious to see if you've done anything with that yet. She asked, all good, thanks. How is your family? They're fine. My wife it was a little bit better today. She's still pretty ill, but it was better. And the kids seem to be also not getting worse. So I think we might get lucky. Hi, Luke is in chat as well. Hey, Luke. Nice to have you here. Merry Christmas. I hope you're doing well. Okay. So yeah, I think I'll just start by reading day 25 and see what they have in store for us. And then maybe we can revisit some of the other stuff depending on how long it all takes us. Amarte says, yes, 25 is done. I've done 24 fast, but because I use other method for intersections, so it worked with no issue. Cool, I might want to take a look at that later and see if I can change mine. I then tried the formula you use, and then I started having problems. Okay, yeah. Well, I got mine off of Wikipedia, so it worked for the test input, but yeah, it's a problem with the larger input. I think there are like multiple ways to do this, and of which I knew none, so I just picked one that I saw. But yeah, might be fun to check that out later. But first, let's see what day 25 has in store for us. She says the formula is good, but not for such big numbers. Yes. And I wonder if I'm not sure. No, because it wouldn't matter. I was like, if you take a larger sample, just not the one step, but like 1,000 steps. If you take a larger sample, if that would have an impact on the precision, but we'll see. Let's see. Snowverload. Still, somehow without snow, you get to the last place you haven't checked. The center of Snow Island, directly below the waterfall. Here, someone has clearly been trying to fix the problem. Scattered everywhere are hundreds of weather machines, almanacs, communication modules, hoofprints, machine parts, mirrors, lenses, and so on. Somehow, everything has been wired together into a massive snow-producing apparatus, but nothing seems to be running. You check a tiny screen on one of the communication modules. Error 2023. It doesn't say what Error 2023 means, but it does have a phone number for support printed on it. Hi, you've reached Weather Machines and So Incorporated. How can I help you? You explain the situation. Error 2023, you say? Why, that's a power overload error, of course. It means you have too many components plugged in. Try unplugging some components and you explain that there are hundreds of components here and you are in a bit of a hurry. Well, let's see how bad it is. Do you see a big red reset button somewhere? It should be on its own module. If you push it, it probably won't fix anything, but it'll report how overloaded things are. After a minute or two, you find the reset button. It's so big that it takes 2 hands just to get enough leverage to push it. The screen then displays System Overload. Connected components would require power equal to at least 100 stars. Wait, how many components did you say are plugged in? With that much equipment, you could produce snow for the entire, and you disconnect the call. You have nowhere near that many stars, and you need to find a way to disconnect at least half of the equipment here, or it's already Christmas. But it's already Christmas. You only have time to disconnect 3 wires. Fortunately, someone left a wiring diagram, your puzzle input, that shows how the components are connected. For example, so one connected to many for each of them, okay? Each line shows the name of a component, a colon, and then a list of other components to which that component is connected. Connections aren't directional. ABC, XYZ, and XYZ ABC both represent the same configuration. Okay. Each connection between 2 components is represented only once, so some components might only ever appear on the left or the right side of a colon. In this example, if you disconnect the wire between HFX/PZL, the wire between BVG and CMG, and the wire between NVD and JQT will divide the components into 2 separate disconnected groups. Okay. If you disconnect this wire, and this wire, okay. 9 components there and 6 components there, okay. Multiplying the sizes of these groups together produces 54. Find the 3 wires you need to disconnect in order to divide the components into 2 separate groups. What do you get if you multiply the sizes of the groups together? Okay. Okay. Not quite sure yet, but I'll manage. Day 25. Here we go. This is our test input. The answer was 54 for this one. Oh, come on. So now we need to do a many-to-many relationship map, which basically means we have a dictionary of string connected to a hash set of other strings, which is a module mapping. Like this. Okay. And we can trim by white space, and then, like for the first one, we remove the last character, and that one will be all. So let's do that. We do input.toLines, and then we do select l.split by ASCII white space. Boom. Let's see, Marty says, fun fact, I saw on Reddit some people translate the format, put the graph into graph visualization soft, look for the line manually, and then hard code the connection to remove. Yeah, I'm sure that will work. First, let me parse the input, map it 2 ways, and then see what we have. Let's see. Boom, boom, boom. Where was I? Oh yeah, like this. Basically what I can do is for each var this would be a list of string, right? Yes, or an array of string, and because I did this, that is fine. Parts, okay. So now I can do var from is parts 0, and then we do something like this. We skip the last one. Var other is parts dot skip. Oh, actually I can do it just like this, right? One, boom. Not that it matters. I could just do a for int I is 0, actually 1, I is smaller than parts of length plus I. If not, module mapping that try get module mapping try get value from out var connections, and we do connections is new, and we do module mapping dot add like this. I forgot a comma here. And then we can do connections dot add parts of this. And I can do 2 is parts I, like this. 2, same thing we do here. We get the inverse and build up that mapping as well. So we do if not module mapping try get value 2 out var inverse connections, and we do inverse connections is new, and we do module mapping dot add like this, okay, and then we can do inverse connections dot add from. Okay, so this will build up the entire list of everything from and to. And the idea was to have a somewhat split. So this one is 9 and 6. This will be, okay. So you have to, they are now all interlinked, probably. And then you have to make sure which cuts you can do to actually create 2 separate groups. I could brute force that. Var options is module mapping the keys that permutate 3 allow do false, and I can do it for each. Var option in options. Let me think. So then I can do module. Actually, we need pairs. Well, this is still fine. So I can do module mapping dot option. Let me see. Is this is an IEnumerable? So what we need to do is actually string say like this, and I can do a, b, c. is option as value 2.3. Now I can do A, but there's no guarantee that it will have those connections. Ooh, this is a lot of options actually. Because what I was thinking is like I could generate every combination of 3 modules and then try every random disconnection between them and then see if we follow either side, because 3 pairs means 6 modules, and then you have to see how many distinct connection states that you find from there. Boom, boom, boom. So before I do this, I also need to do something that will just dump me, will get me all of the connected pairs. So IEnumerable, no, hash set string, get all connections, string start, and this will be a dictionary of string, hash set string, all connections. Something like this. Let me think. Yes. Actually, what we need to know, you kind of want to isolate the nodes that only have like, that bridges 2 complete big sets. And then let me just dump out all of them with the amount of connections they have. So before I finish this, let me just gather some information here. So we can do for each farm, actually string module in module mapping the keys. We can do console.writeLine like this. We can do something like this. Sure. This will be module. This one would be bar connections is module like this. Strong type that. Come on. Explicit type. Can do it like this. Boom. And here we can do string.join. Like this is fine. Let's set up that we want to run day 25. Build errors, great. That was me messing about with day 21. Let's run this. Okay, there's actually, all of them have a lot of connections. Okay. That is surprising to me. Okay. Because they say HFX would cut the PZL1. That one is connected to HFX.
Actually, what would be interesting, like if you have A here, sorry for the horrible MS Paint drawing. If you have A here and B here, they have like C and D and E and F and G and H. What would be interesting is to know past this boundary how many of these connect to these. Many A, B and other many. You can have a situation like many to A, yeah, A connects to B and then other to many, yeah. But both groups will have just one connecting edge, yes. That was what I was trying to say, like if this is the connection, you want to see how many of these can reach this way. So for, like basically for each one of these, you want to see like if this one is connected to this one, you want to know that how many of these can connect to this one if this one wouldn't exist. No, wait. No, the X. Let me see the X. This one here. So if you look at this one, you want for each of these, you want to know how many of these can connect to these. That would give you some, I think. It's always easy when you visualize stuff, but I would probably have to visualize the chain and like yes. Let me see. For each var this, so we want to actually do a result dot add start. Do I want to turn this into a queue? Probably. Let's see. Queue string to process. Boom. Like this. Yes, you want to do this at the same time so you don't actually have to do a lot of work after. While to process count larger than 0. Var target is to process DQ. Like this. If not, result that contains connection. Result like this, and we do to process NQ connection. Return result. Okay, so this one should be able to give us all the connections based off of one set right now. Do we want to know the distance to that as well? That might be interesting actually. Something like this. It's more interesting. Dictionary int result is new. To process this one is 0. Int this distance is 0. Contains key. Add comma module int distance like this. Okay, like this. We add target dot distance +1 module. Okay. Boom, 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 boom. Fine, okay. I'm really not gonna do this right now. Module mapping keys first. Module mappings, okay. For connections, this. For each var connection like this, sure, console.writeLine. Alright, like this, right? Connection. Sure, okay. Might be fun to do this for every one of them, actually. How many permutations would it be, actually? 455, that's a lot. Where did I do my... Ah, okay, I did that here. I really need to come up with a better name than connections. That's a workaround. I need to pass in the actual thing. So you can see at several distances, you can see the same, somewhat the same amount of groups. Does this give me enough information? Let me see. They say we got PZL, HFX, BVB, CMG, and NVDJ QT. So let me see. BVB and CMG. This one is interesting. It only has 2 deep. The NVD is only 2 deep. Okay, so the first thing that I notice is that NVD and PZL only have like 2 levels deep here. Those are 2 of the cuts. This one also has 2 levels, the CMG. Was there another one with the shallow? No. Let's go past it. Let's see where is the BVB one. This one. FRS. Okay, so fun to look at, but still not enough information to make a sensible decision there. At least now I can know how big they. Let me see. I think they can always connect to all of them, right? Let me see. Get all connections. CNN. This. CNN. So this one would be CNN.count. I think right now they can all reach every one of them, right? I assume this count 15, 15, 15. Yes, okay. Okay. So now if I take out these connections, I would get 2 isolated groups. So let me see. Let me just do a function here, void snip, string A, string B, and then let's have our signature here. So that would be mapping A that remove B and the inverse. Okay, let's see if we do this. This would be hfx pzl bbb cmg nvb jqt. Okay. Boom, 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 boom. Console, the right line. Doing test cuts like this, okay. Okay, so at least that is just how it is expected. Now I wonder if I would just brute force this, but I wonder how this actually looks, how this visualized in the graph. So now I wonder if I should actually build this. Because what I need to do is actually figure out like the distance one connections between every one of them. And Martin says, so hard coding edge to cut it is. No. I just wanted to see if the code would pick it up and how it would visualize. And I just tried to do step by step. And because what I need to do is actually validate in the end which unique set of pairs there still is, right? Let me see. I know, just kidding. Yes, I know. Let me see. I wonder if I would like take all of the connections and take like all the distance one, like from between these and these, like see how many times which ones in the middle would come up there, like how many bridging connections there are. Would that be the way to go? Let me see. For like if I like what I want to do is get a permutation of every combination, so a pair of two, and then find the distance between those two and actually which one connects them. So I think I want to do that right now. So let's see, var pairs is module mapping dot keys dot get permutations 2. We don't want dupes to array like this. Now we do for each var pair in pairs. Let's see, what do I want to store? Basically, it's this thing. But a lighter form. Find connection between string A, string B, Let me see. Now I would need to have the full path here, and I need to know for each individual how they connected. So I need to write this a little bit different. So this one would basically be a list of previous steps. So this would be a list of string previous, something like this. This one would be A. Basically just becomes a list of string. We don't care there. We need to have a hash set scene. It won't be the fastest, but it's not a large list, so I'll just do a contains on this one, even though it's not optimal. It's fine. Let's see. If connection equals B, return target dot previous dot add B. In this case, return target dot previous. Else, if not target dot previous dot contains B, we do to process that enqueue. This would be, let me see, connection dot, just connection, and then we do targets dot previous dot to list, no, dot to list. Can I do this one now? I've never used it successfully yet, and this would be connection, right? Nope, okay. Actually, I can just do return new. Like this. No, module mapping. Okay, like this. Okay. Bum, 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 bum. Dictionary string. Come on. List connection path like this. Something like this. What's the matter? Why is it complaining? This is my key type. Ah, I can't name this one. Okay, let's do connection paths. Connection paths add a comma b connection. No, also write this out right away. Console.write line. Come on, write line. Count. And then we do string.join and connection dot just like this. Let's see. I'm about to say something along the lines of what I was thinking now when I saw the visualization of the graph to check which edges are the busiest. Yes. Oh wait, what is happening here? I have an infinite loop somewhere. To process is infinitely large. Okay. Let's see, what is my queue like? NTQ, JTQ, page of X. Wait, what's the issue here? JTQ and HRN. Like, where's JTQ? Oh, we need to go to this one. JTQ, where are you? JTQ. And then HRN is in the first level. Okay, why the... Okay, so this one is fine. JTQ versus X. JTQ. Come on. This is a second here, so this one should also be fairly... Oh wait, it didn't add itself here yet, which is not correct. Let's do it like this. That's okay. Smap UK, good evening. I hope you had a nice Christmas. Welcome. Did you do part 25 yet? Day 25. Ha, it's been a long month. It's nice to have you in chat though. I haven't watched Captain Coda today, so I have no clue how he fared.
When I haven't done the day, I try to not watch people do it. So I have some things to look forward to. SmabUK says, I have, but I'm not happy with how. Okay. I'm still in my exploration phase. And I had a bug where I had a very, very big queue. So I wanted to find out how that happened. Okay, so this is also fine. So let me actually see. Let this run and see when it hits the infinite loop. Okay, boom. What is actually the AB that it's trying to do? So let me see. A is JQT and B is NVD. Okay. So let me just set a breakpoint before I do this. If A equals this and B equals this, okay, console.line, boom. Actually, system.diagnostics debug.writeline. Let's do it like this. Let's stop and run again and see what's happening here. Yeah, this is fine. SmapUK says, I spent hours trying to implement some min-cut algorithm that I've never heard of. I even asked ChatGPT to help, but I spent 3 hours going around in circles as it seemed to know even less than me. Yeah, I've tried to have ChatGPT translate or fix something for me, but it's useless. If it's not the most absolute basic thing, I end up teaching it more than it teaches me, so yeah, I've given up on that. Okay. So let's see, we are trying to do, let me just get rid of all these watches and add some watches here. Eventually I discovered Graphis, and I'm one of those that eyeballed the answer. I won't judge, I won't judge. My issue is that I just need to have a global scene state here. Hash set string scene is new. Because it really doesn't matter, I think. Does it? Let me see. No, because it tests against that. It should be fine now. Let me see. Yeah, I think I only need to queue it once. Something like this. Does it complete? Do I still have an issue? Okay. What am I missing here? No, not what the... What is happening here? Okay, let me just go back to
the not seen, because I think that was probably okay. So I have no idea what's happening here. Let me see. I've been coding over 45 years and I've only ever used graphs in advent of code. Yeah. Amarte says, let me see. Let me catch up on chat. Snap UK says, I'm still looking to find a computational method, but I haven't looked at Reddit all month. Well, that's I can commend you for that. Amarte says, I got lucky actually. I got myself a book about graphs a few months ago, and it so happened there was a working algorithm. Ah, nice. I still okay. Boom, 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 boom. Let's step into here. Do I never add it here? Yeah, on this level it doesn't matter, because I add the clone like this. So you have that one, that's not in it. Let's also do, we add a watch for this one. Okay, so now it's the second level. Sure. But this one, so the global scene would actually prevent me from going back right now, but let's see. Because JQ to NVD, what was actually the connection there? JQ, NVD would be the third one. Okay. Shouldn't it have been like in the first step? Shouldn't it have already returned here? Let me see, to process. JQT. Okay, let's step through it again so that I'm not going crazy. Test JQT, and now the connection thing is HRN, because this one should give us, like, the B one is in this one. It isn't. Wait, what? Did my... Okay, so my clone is probably altered here. Okay, let me not do the snipping because the clone that I make didn't work. I think that might be the issue here. But then still there's something wrong with the... there's something wrong with what I did. Because it should never just keep looping. Okay, so at least now it can find the connection. So it was actually the fact that there was an issue there. Okay. Okay. Let me see. Got a message from home. Let me quickly check that. Okay, everything's okay. So let me see. So now what I need to do actually is to find out, like for everyone that has more than 1 degree, I think I need to have a count to see how many times they are at the center of those. So you can see NVD pops up a lot here, NVD PZL, NVD QNR. So NVD and PZL are some of the ones that we want to look at. Actually, I wonder, should we always look at the 4-pair ones and then see which one of these? Yeah, I think we have it here. HFX, PZL. Nice. I think I actually have it. Where's the BVB one? BVB CMG in here. Okay, let's see. So let's see. For each. Exit value. So if we just ignore everything that has only those amount of connections. Okay. So now we have NVD PZL, and probably we need to have this in both directions. So we should consider every step of these, and we should probably have a count there. So let's see. The NVD PZL, is that in here? No, it's NVD JQT that we want. Actually, should it be every pair of 2? I think we need to take every one that is 3 connections or more, so shrink one down. Sorry. Okay. And then count every pair there and see which one is the most used. Okay. So it would be larger than 2. So anything that doesn't have a direct connection, which means that it will be impacted by cutting. And then we need to like zip, I think. I never used that. Sure. Is it something like this? If our pairs is this. Something like this. Let's do dictionary string A, string B, int count, just int. Snippable count is new, something like this, right? So we can do for each var as in this. And I actually want to have them sorted. Let's see, if large than 0. Okay, then we can do like the key. And then we can do if snippable count try get value key out int count. Okay, come on. If not, count is 0, and then we can just do like this. Something like this. Then we can do for each. Actually, we can do yeah, for each var as in snippable count, order by descending value, console the right line. No. Okay. Okay, why is this? What's going on? Where are we running? So I don't understand. Now it's like sometimes Visual Studio is just weird and it will hang on stupid stuff. So let's restart Visual Studio. Let's see if what I'm doing actually makes a bit of sense. Okay, boom. Okay. So let's see if this produces the thing that we want to see. And otherwise we can just try these. So JQT NVD, yes, match. PZL HFX, match. PVB CMG. Okay, so the top 3 matches here is what we want. Nice. Now all we need to do is, after we do that, for all the 6 connections, try to find how many unique pairs there are. Which is not as easy. Well, it is fairly easy, but it's annoying. So we can do var to snip is this dot take 3. Sure. Module mapping. And now we need to see if we can produce unique sets. Let's see. Pairs to check is to snip. Come on. To snip. Let me just do it like this. And then I can do fascinating to see if the top 3 is the answer for the biggest set as well. Yeah, but if not, what we can do is just take that as the educated guess and try some combinations, right? So right now I'm writing the validation code to do the snip and then see if we end up with 2 distinct sets. So if not, we can just, okay, go to the top 4 and take the permutations of that and try that and then expand. Okay, Luke, thank you for the good luck wishes and I hope you have a nice sleep/rest. How long have it been going for? Over an hour already. Okay, I thought it might be a quick one today, but not that quick. So yeah, let's see if this works. So after I've done those snips, I need to have a dictionary of string followed by a hash set. No, actually, find connections. No, actually, I need to. What was my method? Get all connections. Yes. Then I need to do get all connections for X, followed by module mapping here. And I can just do actually the select x dot key in this case, and then order by then I can do string set is string dot join, come on, like this, something like this. And I can do hash set string unique connections, unique sets is new, and I can just do unique sets dot add set console dot actually I should probably do it differently. Like this. Come on, to array. Then I do CNN here, and I want this to be a dictionary actually, like this. And I can do if not unique sets that contains key set unique sets dot add set comma cnn dot count length. So that way I don't have to count again, and I can also just get the answer, because like p1 now should be unique. No. unique sets 0 times unique sets 1. What's the issue here? It's not null here. Yeah, I know. Bum ba dum ba bum. Oh, actually. It's something like this, but only if the count is 2. So if unique sets unique sets that count. Right line like this. Then we get x dot key okay. Nice, that passes. Let's run it for the real input. Oh, I forgot some outputs. Photosensitivity warning. Let me just stop this. Console.write line. Actually, this whole thing is a if tests, right? Yes. Never mind. Oh, it doesn't like my code. Find connections between A and B. How big is the queue? It's very big. So this is the issue that I had before. Wow, wait. This is evil. Why are there so many pairs? Yeah, this is very, very evil. $1.1 million pairs, really? I mean, it's still doable, but not if my find connection between logic here is flawed, which is a pain. You say like you've never done any yeah, I didn't expect this. Let's see. I naively thought I could use combinations when I started, then it broke my routine trying to generate them out. Yeah, but now I still need to fix this thing here. Are they all connected now? Probably. Let me see. Oh. I'm an idiot. So this is what... I should make like a quick cut of every time I say I'm an idiot. Let's see. SmapUK said, I wrote a version that worked for the task input really quickly, then life got hard. Yes, I can imagine. Okay, let me see. How big is... It's still pretty big. But now at least it's not nonsense, right? Let me see the pairs logic. Yeah. I want to see how fast this goes. Okay, let's scale it down. Finding 1,000, doing 1,000 of them is already an issue. And there should probably be a lot of caching that can be done already. Sunco Suffer says, the last AOC stream. Hello. Yes. Okay, so this won't work, which is very annoying. Because it works so well on the test input. Let me see. So now what if I just take every connection and weigh them like this? Would that do the same thing? Let me think. Not the unique snaps, this part. Let me see. If I just do this and I do if I just build out every pair here, so I can do for each var over in x dot value. I could just call it b actually. Boom, 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 boom. Did you have a nice Christmas, by the way, Sunko Software? I actually spent the evening watching Home Alone with my daughters. They hadn't seen it before. They really liked it. The oldest one said it was even better than Encanto, so she had a great time. Let me see, like this. If it's not there, we add it, and otherwise we increment it. So sure. Yes, very nice. Ah, good to hear. Now let's go and run the alternative one instead of this one. See what that does. Nope. Wait, what? Separates one pairs. Ah, yeah, because I need to have the full path between every one of them. This is so annoying. How else can I do this? Could I do... If I do one more level here. And we do for each var C in module mapping B. If C equals A dot key, X dot key, continue. So this would give us ABC. Let me just do something like an action string track is A, B, something like this. So here we can do track X dot key B. And here we can do tracks X dot key C, and the same for B. Does this make sense? Let me run this. It's somewhat better. The thing is, we want to exclude all the direct connections. We only want to track AC. Not really, but let me see. I think I actually need to remove this one. Let me see. We also want to track XP once. This is annoying.
This is a tough one. Without doing all the permutations and getting all the chains, it's a nightmare. Do I know of a way to fix this? Is there a way to make this easier? Okay, so this is also not the way. Let me see. Smappy says, welcome to my nightmares. Yes. I kind of want to let it run now, just so that we get a... Okay, let's go back to part 1 and see how fast it really is. If like... How much work it would... How much time it would take to run. Wait, what? Ah. I was like, who? What happened? False. Come on. Right, this is fairly fast. So I think there might just be something wrong with my... No, okay, this is also still... Okay, that one takes 11 steps. So are there some really weird long ones or something? Okay. Let's just go. Okay, so there are some ones that it finds really tough. And at this pace, 1.1 million is just not doable. Can I think of something else to make this easier?
I'm wondering if there's like a way to build up the entire map. Like an A to B for everything. So like if you start at the first one, because we know they're all connected, right? I've been going over 6 hours when I resorted to graph this. You barely started. Yeah, okay. Basically my idea was like, okay, I can go over and I don't even need to do the pairs. What I can just do, I have the module mapping, right? I can go over each one, then find the next set, and then carry over the no, I should probably just write it out. So my idea is more like, okay, we have parsed this. But now we do the same for each var. We have the one-to-one, but we need to have like a distance dictionary string. So my idea was, if I have a queue, and I can do a stack as well, it doesn't really matter, but queue, and this one will be a string. No, it would have like all the things that it did in the past, and then string to process, something like this. So now we would have the enqueue, and it would be a new dictionary here with like module mapping dot. Oh no, I can actually do it just in here. Can do entry dot yes, entry, and its value would be, current distance would be 0. So it would be like this. The only issue is that it I would have to do the inverse probably. Let me see. While q.count larger than 0. And we can have a global hash set string. Scene is new. Scene.add entry, something like this, right? No, that is not true.
Well, my idea was like I could go over like one level, take all of them, record the distances, then go to the everything below that, and then add like the relation between those two, but also take every other thing that we've seen in the past and add one to it. Because like var x is q.dq, no dq. For each for direct in module mapping q x dot to process, yes. These are direct connections to x. X has distance, in this case 0. We are currently int current distance is x dot is actually x dot past. We need to get ourselves out of that like this. So now you would have this distance to every entry in x.past would be cd minus the value in dictionary, right? Something like that. So this would let you build up a AB connection with the length. But that still doesn't get the other paths in between which we need, which is a pain. No, this isn't gonna work. No, I don't think I can do this with code as the way that I want to do it, which is annoying. Trying to think of if there's a way to be smarter. But I'm coming up short. Because I was glad that I could actually solve the sample input with an approach that I came up with. Because for me, like, I don't think it's
I'm just wondering if we could the thing is we just need to do a few snips. So is there a way to just take every single one of them? How deep would we have to go? Like the thing that I started at, like the ABC one, Smap says I finished with 45 stars this year, so at least I wasn't completing this one to get my fit. No, mine either. I'm at 45 as well. So my thinking is, would it be possible to just limit yourself to 3 connections and then count this one and this one? But the thing that I really liked was that I could find all the ones that aren't one-to-one connections. Wait. I have an idea. My thinking is like, let me see, if I do the test code, test is true. If I limit to, I have larger than 2 somewhere, right? If I limit this to just evaluating the ones that have a length of 3. No. That doesn't do the trick. So what if I limit it to just the ones that are 4? Nope. I don't think. I think the whole thing of like evaluate everything that's separate, that's not directly connected, I think that is the way to go. How do I optimize this for a very large data set? So what I could do is prune the pairs before doing that and just taking every one out of it that has direct connections. So I can do that. So let me see. Pairs is pairs where shit. I said nothing. Let me see. Probably doesn't make it a whole lot easier or faster, but let's see if we can do one last attempt. And if this doesn't work, I don't think I'll continue after that. So if module mapping A contains B, if this isn't the case, then we do non-connected pairs that add A, B. Okay. And I should probably do the sorting thing that I have here, just to make sure that I don't have to do that over and over again. Doesn't matter. No, these are already unique. It doesn't matter. It doesn't matter. It's fine. So now I can do console.write line. Like this, and then I can do like this. I mean, that obviously still makes part 1 work. Let's see how big of a reduction it is for the true case. Haha, okay. Still sneaky little bastards. Only 3,000 direct connections. Do I have a printout here? Let me see. At least this is a long, but this is an int and this is an int. Okay, stop. Actually, I can just... I'm going to let this code run while I sleep and see if I have an answer tomorrow. Unique sets. This is fine. I'll do long length just so that it's a long and then it's fine. They multiply and it should be fine. So yeah, I'm going to let this run. I'm really curious actually if this code would get the answer that we need. That's why I'm leaving it run, just to know if the hypotheses of the whole Swampy says that's wishful thinking. I let mine run for 3 hours while I was working on other methods. Okay. Yeah, I know. But it's almost at like 0.1%. I mean, it's not that bad. And then your computer crashed. This one doesn't crash, knock on wood, but... Nothing to do with the running of the code, yeah. Should be fine in all sorts of ways. This was just million, right? 1.1 million? Yeah, okay. So there, I think it should be able to run this by completion. I'm not sure if it will be tomorrow, but let's see. Bit of an anti-climax. I really wanted this to work, but yeah. So did anybody figure out a way to do this other than visualizing the graph? Because basically what the graph visualizer does is something that we want to do with our eyes. And yeah. My estimation says around 100 hours at this pace. Could be, could be. I should just leave the stream running and then you can add me when you see that it works. Oh man. Yeah. Yours says a bit longer, yeah. I'm just gonna, for fun, I'll just leave it, and because I don't have anything to do tomorrow on the office PC anyways, I want to do lots of stuff with the family. So, yeah, I'll just leave this running for fun. It seems to be slowing down. Well, it depends on the amount of connections, like the finding of the paths. It really depends on how long the chains are. And I think I've done something stupid there with the path finding, because it sometimes queues up like 55,000 deep. Well, there may be those big paths there, so who knows, but yeah. So the rate is variable depending on how deep the connections are. Man. I actually wonder if I would take like a subset of the data, like a sample, and see if we could already deduce the numbers based out of that. So like if I would just take, but then you'd have broken chains already, that's the pain. Amarte says the way I did it is unstable. That's the nature of the algorithm. It can give the answer to live data in 700 milliseconds or in 20 seconds. It has randoms in it, so that's expected. Okay. So do you do random cuts and then just see what the answer is? Or I looked at various min cut algorithms. For me, I think like the what I think was really cool is that I haven't done a problem like this before, but the fact that I managed to come up with a way to analyze, and that's why I want to know if it holds true for the real data, that I found a way to actually tackle this sample problem and figure out a way to get a nice answer. I thought that was cool. So I'm really curious to see how it performs on a larger data set. I just wish it wasn't this large. Let's see. Pretty much I did Karger. It selects cuts in a somewhat random way and then I check the result. Yeah. Okay. I'm just trying to what I'm trying to do is visualize okay, how would the graph look like? And try to see if there's a way to get to that state in code. And Martin says there's also Stur Wagner, better but still does random. Okay. But given the problem, the fact that you can do 3 cuts to separate the whole thing means that if you visualize it, it should be fairly obvious from the way things are connected. But this is so big. See, I didn't understand either of them well enough to implement them properly in C#. Okay. It's an interesting problem for sure. Is there actually a visualizer that just takes this input and shows it to you fairly easily? I've never used any of those visualizers myself, so I was just curious, but yeah. Yes, okay. And Amarte says, I wonder if a neural network could be trained to look for this cut and give the answer. Well, the whole issue I have is that if there's a visualizer out there that can visualize it, and then we can visually scan it for the properties that it needs, there should be a way to codify it as well. But the thing is that how do you do that? Actually, what you could do, maybe, is have like a left-right weight. So that you count for like every pair, you count how many are on the left, how many are on the right. And then you probably have to compare like the left and right groups to see if there's any commonalities there. Something like that. Mate says, I was thinking maybe do a path finding from every node to every other node. Those that connect two big groups should be the busiest ones. Yes. Yeah, that was somewhat what I wanted to do, but yeah. Well, would it be? But because basically that is somewhat what I'm doing right here. But that's only, I only look at the pairings that don't have a direct connection, and then I see what is the most common factor there. So basically that is the idea that you have, right? Because that's the busiest intersections. But what you have to do is exclude all the ones that have direct connections because they don't matter. So if you just look at all the nodes that are separated by at least one other node before they can interact, then you take that's the logic that I wrote for the test case here. So then you look at all the, like if you have the three nodes, you take the left and the right pair, and if you have more than two separating one, you take every possible combination in that path. You count one for each of them, and then you just look at the one that occurs the most. And for the test case, that works. That is the logic that I wrote. I just wish it would let me evaluate this against the against the real data. And San Christopher says benchmarking goes brrr. Yes. But I really don't like that this is this slow, because like the part that's running right now, this one, like to find the connection between those two, it is so slow. And I think this would be a benefit from like some caching. Smap UK sent me a message on Discord. Let me see. Oh wow, what's this? Bzz. Oh wow. Oh yeah, that's really clear. Interesting. In this case, do these important nodes only have very small connections? Uh, Same number of connections. Let's see. What I can say is Karger and Store Wagner are recognized minimum cuts, so maybe random is the answer. So like, how do we codify this? In a way that doesn't blow up the CPU. Because like the fact that it can draw this means it has to evaluate a lot of stuff and it can count its own properties and so there has to be an efficient way to do that. It's just eluding me, and I think the biggest issue is that my find connections between is just very inefficient, right? If I do like this one, it has, this isn't correct. It has 1.2 million entries, which should not be possible, right? So that's why I'm saying like my find connections between is wrong. This basically does a BFF. Ah, wait. Would that matter? Because this one, the issue here is that it will search the same space over and over and over again. So I should have probably written this with a recursive function with a cache. Because then it would have been a lot faster. But I don't have the energy to do it right now. I think I'll just end it here for today. I've had fun. I will revisit this at a time when I've recharged a bit. But yeah, it was fun. Advent of Code was fun this year, and I have a few challenges to look forward to revisiting. Like, wait, did I see something in? Let me see. To claim my firmware nice up. Okay, I'll check that later in the Discord. I don't blame you. Yeah. it has been fun. For like, I need to revisit yesterday's one, and Amate says that she had an improved algorithm that I could use for that part. And for part 2, I heard somebody else. I watched a video where they went into part 2, and my basically it's you need to find a rock that you can shoot to hit everything in the problem set. So my idea was just to find the intersection between every one of them, and that should have a somewhat scoped out area. So like it should be like a line in 3D space, somewhat, like with some margin. And I think that I can use that to try some values and get it. But first I need to actually stabilize the function that will let me do this. So yeah. And then there's still day 21 part 2 with the diamond shape. I actually quickly looked at the quadratic formula, but it was like, okay, I need some more time to just figure that out. So yeah, I want to thank everybody for watching me do Advent of Code this year, and keep me company in the chat and help. And I don't think the adventure will end here. I will revisit some of this in days to come, but I will take a small break for a few days and maybe then do some more streaming. And I also want to go back and finish some of the other years and maybe do the years that I haven't done yet. So yeah, maybe we'll see a lot more of each other. So Gustavo says thank you for the streams, and Amade the same. Yeah, SmapUK says good job. I remember you had to quit early last year. Yeah, it was not due to the difficulty, but just due to time. I had to stop around, right before the end. I had to stop at I think I had to stop at day 16 or 17, and like just before this year started, I went back and I did a few more just before the Advent of Code started. So yeah, it was nice. I still need to do those as well. I think I stopped around day 18 last year because just some work stuff came up and I couldn't continue. So yeah, still lots of fun to look forward to. So thank you. I hope everybody had fun, and yeah, hopefully see you in a few days. And if not, have a nice Christmas and a happy New Year, and see you in